Hello there, my dear students. I hope by now you are busy studying the chapter on work and energy. So for this video, I'll be discussing another example on the application of the conservation of mechanical energy. I got this from University Physics by Young and Friedman. Okay. So the problem goes like this. You have a rocket here that is about to be launched. But before, the launching is done by allowing the rocket to slide down a ramp. And the ramp is relatively steep, no? Because the angle is quite big. It's 53 degrees. Okay. The mass of the rocket is given as 1,500. Ayan, you have your mass there. And then it says here that it is to be launched with an initial upward speed of 50 meters per second. So do not be confused with the word initial here, no? Uh, do not be confused na you will equate it as the initial speed of the rocket at the top of the ramp. No, it is the initial upward speed. So meaning to say, the rocket is launched upward. So this 50 meters per second, this is when it uh, leaves the bottom of the ramp. So if we take the point at the origin of the rocket as point 1, then the bottom of the ramp will take it as point 2. So this 50 meters per second, this is actually the launching velocity or a launching speed of the rocket uh, when it is launched upward. So meaning to say, we'll take the 50 meters per second as our speed 2. That's the final speed with respect to point 1 and point 2 na events. But when it's launched vertically, then that 50 meters per second becomes the initial speed when it's already launched vertically. Okay, but we will not go into that part of the problem. Ang concern lang natin is while it's moving from the top of the ramp down to the bottom of the ramp. So our V2 here will be 50 meters per second. So ito yung, let's just say it's somewhere here, no? At the bottom of the ramp. So whatever is the rocket speed here, yun na rin yung launching speed niya. Ayan, wait, let me charge my laptop. Okay, there. Now, in order to assist the rocket's engines, the engineers will start it from rest. Yan. So, ito na yung clear ngayon na at the top of the ramp, it has to start from rest. So, immediately we say that it has no initial speed with respect to point 1 here above the horizontal. At the bottom of the ramp, it turns upward and launches vertically. Thus, the engine provides a constant forward thrust of 2,000. So from when the rocket was released at point 1, its engines can provide an additional 2,000 Newton forward force. Kasi that's the thrust, diba? Thrust, there's that. Thrust is a force that will push the spacecraft or the rocket here uh, along the direction of motion because the lift will give it altitude. Okay, ayan. So meaning to say, with the rocket somewhere here initially at rest, it receives a constant 2,000 forward thrust. So we call that thrust as F sub T na lang, ganyan. And it's 2,000 newtons. But there's also a constant 500 frictional force. So if the rocket is going downward, then we know that friction opposes it. So we'll call this as specifically kinetic friction. And this is 500 newtons. The question is, how far from the base of the ramp should the rocket start as measured along the surface of the ramp? So how far? Meaning it's talking about distance or length. Okay? So specifically, we are to determine how far should it be. So anong length, in other words? What's the length of this ramp? Okay, the length of the ramp which the rocket should travel so that when it is launched upward, it will have a speed of 50 meters per second. So we will call this distance along the ramp as distance, say S. Yan. Okay. Now, we will now apply the conservation of mechanical energy. So we've already uh, defined points 1 and point 2. So if we take this, the horizontal surface as the reference for the height, we'll take this as y equals 0. We say that it's the reference. So that immediately you can remind yourself that from this point to this point, this is initial height 1. We'll call this angle 53 as theta. Okay? Therefore, at the bottom of the ramp, that is where the height is 0 at point 2. Tama ba? Okay. Now we're ready to establish our equation. There's a change in height, therefore, there is work done by gravity. So, meron tayong change in gravitational potential energy. Meron tayong UG1, UG2. There is also speed, no? So, there's kinetic energy. Now, the forward thrust due to the engine is not conservative, so it is considered as an other force. The same thing as friction. Friction also is non-conservative because the work done by friction depends on the actual path taken here. So we can say therefore that the total work other, okay, would be, we have I'm sorry, total force. Force muna, not work. So, other forces, we have, this would be the force of the thrust plus kinetic friction. Okay? Now, we take going down as negative and then up is positive. So, we say therefore that this becomes 2,000 positive minus 500. So we only have here another force of 1,500 newtons. Now, since the thrust is greater than the friction here is negative, diba? So therefore, the total other forces is positive. So the work done by this force would also be positive. Bakit? If you notice here, the displacement vector is downward, and then the other force, the total ng dalawa is also downward. So since the force and the displacement are going towards the same direction, then you know that the work done by the other force will be taken as positive. So this is important in our equation in the next step. Okay, so our equation now, kinetic conservation of mechanical energy. So we have kinetic 1 plus gravitational potential 1 plus work by the other. There are no springs involved, so there's no elastic potential energy. There's no work done by the spring force. So we will not put U elastic here anymore. Equals kinetic 2 plus UG2. Remember that the work done by other forces will always be in the initial state. So you do not put work other in the right side or in the final state of your system. Always siyang nasa sa initial state. Okay? We immediately cancel everything that is 0. There's no initial speed, so kinetic 1 is 0. There's no final height, so this is also 0. Okay, so we say therefore that whatever potential energy that the rocket has here because of its height from the reference, it's being reinforced or it's being added by the work done by the engines of the rocket. Kaya yun yung sabi dito sa problem, if you see. to assist its engines. So, meaning, yung energy due to gravity, dadagdagan pa ng additional source of energy, which is the work done by the engines of the rocket. So that, pag baba niya dito, so you have UG plus yung work pa na ginawa ng makina, then the final speed will be much greater. Kasi nga ang tawag dito, ang target dito na speed for launch is 50 meters per second. Diba? So, that's the physical meaning of this part of our equation here. Tingnan ninyo, oh, ito. Yan. So, UG plus the work by the engine, it will now give us a higher kinetic energy. Kaysa sa kung nagpa-slide lang siya due to gravity, hindi gumana ang makina. So, walang additional work, konti lang, hindi ganun kabilis yung rocket pagdating niya sa baba ng ramp. So, that's the idea. Okay? So, now we're ready to put the equivalent expressions now. So we have for UG, mass G, Y1. Okay? Again, take note, we are to determine the distance S. No? Kung saan dapat mag-start siya. How far from the bottom of the ramp should the rocket be placed? Okay. Plus, so we have the F, other, times the distance. Kasi work other is force times distance lang, di ba? And then this becomes kinetic energy 1/2 m speed final squared. Okay, let's further simplify this. We do not know the exact value of y1, di ba? It's not given. But we can write y1 in terms of s so that y1 will be out of the equation and then the variable s will also come out of this first term. So you can use trigonometry there. You have your y here. This is s. Okay, simple trigonometry. This is your hypotenuse s. This is your theta and this is your y1. So if we get the sine of theta, it's opposite over hypotenuse. Y1 therefore can be sine theta times S. Ayan. So we will replace Y1 with this equivalence. Okay, let's do that. So this becomes mg sine theta times S plus F other and then distance S equals 1/2 m v2 squared. Okay, we now have our equation. We can easily solve for s using simple algebra. So we can factor out s from the left-hand side of the equation. So I'll factor out s. So this becomes mg sine theta na lang plus f other equals, you have 1/2 m v2 squared. Let's move this higher. Okay, so we transpose this term on the other side so that this becomes S mv2 squared over mg sine theta plus f other. Now that we have our equation for S, it's time to put the values. Okay, make it a habit class. You have to completely derive the equation of your unknown before putting in the values. Okay, so you have 1/2. The mass doesn't cancel out here kasi may walang mass sa kabilang term, no? So lagay talaga natin 1,500 and this is 50 squared over 1/5. We use 9.8 for G and then sine 53. Plus, yung other force natin is just 1,500 na lang. So, therefore, if we simplify this, so it's around 141.6. So, S, therefore, is 141.6 meters. We round this off to how many significant figures? Let's go back to the main problem. Meron tayong tatlo, may apat, tatlo. So we can just use siguro dalawa or tatlo na lang. Kasi baka masyado nang malayo kung dalawa lang. So we say approximately 142 meters. So medyo malayo siya. if you want to imagine how long this ramp is, usually yung mga the distance between the poste of Davao Light, yan, usually the distance here is approximately 100 meters. So kung 142 meters, edi ganun kahaba. Ay, sorry. Yan. So yung ramp, we're talking about rocket ships here, no? These are not just any kind of rocket. Imagine, oh, this is massive. It's 1,500 kilogram rocket. Okay, not rocket ship. It's just a rocket. Pwede rin rocket ship kung ano nakalagay doon. Okay, so the ramp should be more or less, if you have the rocket here, they should be 142 meter long. So that pagdating niya dito, it will be shut up at 50 meters per second. So that's how to visualize it. No? And then this is a very steep angle, 53 degrees. Ayan. So I hope you will really continue studying and solving problems on your own. Please do not ever forget to read your books, ha? Read your books, and then in addition to that, itong mga lecture videos natin. Okay? Never stop learning. Stay well. Until the next topic. Bye-bye.